these now are representing our CH3 groups. Alternatively, we could have actually built out the CH3 groups themselves. Um, right now, because those green balls are representing the CH3 groups, what we're going to see is we're going to have some different conformations, because these are deceptively small for what the actual CH3 group is, but we do have to consider that these are relatively large, like they're a lot larger than hydrogen atoms. And so for these conformations, what's going to be more important is the actual steric interactions. So bringing these groups close together, keeping them far apart sterically is going to be what we're interested in, not so much those bond interactions that we talked about with ethane. It doesn't become as important when you have larger groups. And so with this one, this is how we would normally draw it out. If we want to look at the Newman projection, we'll be looking down this middle bond here. So this would be one of the carbons. This is the second carbon, third carbon, fourth carbon. We want to look down this middle bond between the second and third carbons. And so that's what we're going to do. That's how we're going to see those CH3 groups and getting close to each other, farther apart, things like that. So when we do our Newman projection, we have, we're looking directly down that bond, and we have the CH3 groups. As we can see, they are completely separated as far as apart as they possibly could get, which is a good thing because these CH3 groups are larger. So this is our staggered conformation, are anti-staggered more specifically because the two large groups are anti or opposite to one another. So this is our anti-staggered conformation. Then we want to keep rotating. So we're going to do one rotation, and we see that we end up with an eclipsed conformation. So this one, the CH3 at the front is eclipsing with the H at the back. If we just tilt it a bit, we can kind of see what it's eclipsing with. The CH3 at the bottom is eclipsing with an H at the front. So this is higher in energy. These two H's on this side are also eclipsed. So this is higher energy conformation than the first one that we had, because now the CH3 group with its bonds to its H's are starting to kind of get in the way with this H back here. Even though it's small, it's still closer than what it would like to be. So that's our eclipsed conformation. Next, when we keep doing the rotation, we're actually going to get to our gauche staggered conformation, and this is where our CH3 groups, we see that everything is staggered, so that's good, but our larger groups are actually closer together than they were in that anti-stagger, that first conformation that we had. And so because these are closer together, it's going to be higher in energy than when they were farther apart. But because everything is still staggered, it's still lower in energy than any of the eclipsed conformations, but it is higher in energy than that first staggered conformation that we had. So this is our gauche staggered, and we do see that CH3 is getting closer to this one. The worst conformation is going to be the next one. Once we do this rotation, we end up making another eclipse conformation, but this time it's worse because the two CH3 groups are actually eclipsing each other. So those are the large groups in the molecule. We want them to be as far apart as possible, but they can't be in this eclipse conformation. This is actually as close as they can get in this conformation. And so this is the highest energy conformation because the two large groups are actually right on top of each other, basically in this eclipse conformation. So we also call that a CC eclipse. As we keep rotating around, we're going to get to this structure here where we get another gauche. This is going to be the same energy as the first gauche that we saw. So we didn't end up drawing this one out as well because it's just the same conformation. And then we get to another, what we call a CH eclipse. So now the CH3 groups are eclipsing the H's, but not the large groups themselves. So they're not eclipsing, but they are eclipsing something. And so this is the second highest energy conformation other than the one where the two CH3 groups were eclipsing. This is second highest energy. And then we get back to our lowest energy conformation where the two groups are completely apart from one another. So we saw 4 important conformations. We saw this anti-staggered, we saw the CH eclipsed, then we saw the gauche staggered conformation, and then we saw the CC eclipse. So those are the four important ones. Once we keep rotating, they just repeat. So we do need to know those four. Those are going to be important for how the molecule sits. And so normally that's kind of why we show that zigzag structure that we started out with, because that is the lowest energy conformation. So that's something to keep in mind.